So the bio I originally submitted refers to one of my first ever jobs where I found myself as a college student standing on a manufacturing line. I was working for a very small company, which the owner used to describe as two teenagers and a guy in a wheelchair. He was the guy in the wheelchair. I was one of the teenagers. And we sold barcode systems because that was what he could find that big companies might buy from a company quite as small and undistinguished as we were. And I was on their manufacturing line because this large company had misplaced $1 million worth of truck axles. And I don't know if you've ever seen a truck axle up close, but it's about the size of one of these tables. So truck axle manufacturing companies don't actually have a lot of problem with employee theft. You really can't take one home in your lunchbox. Nobody actually wants to steal a truck axle. So in order to lose $1 million worth of them, which is, not hundreds of truck axles, but it's a number you would notice lying around somewhere, you really have to have lost them. In fact, you have to be in the situation that either you shipped them to a customer and forgot, or they are somewhere in your factory. You just don't know where. And they had no idea which of these situations they were in. And this was kind of my first exposure to the world of big companies. Here I am, I'm in college. The first big company I run into is a major defense contractor that has managed to lose $1 million worth of truck axles. And furthermore, we asked them a couple of, scoping questions. So about how many truck axles a week do you make? Oh, lots, they say happily. Could you put a number on that? Not really. Okay, so on Monday, you schedule how many axles? Oh, that we know. On Monday, we schedule 157 truck axles every Monday. Great, and on Friday, how many of those have you not yet finished? Dunno, no idea. Okay, so about how long, on average, does it take you to make a truck axle? Oh, most of them go out the door right away. Okay, what's the longest possible time it could take you to make a truck axle? How many truck axles do I have to keep running? No clue. I would like to tell you that my experience of competence in large companies has improved since then. But I'm afraid that along with one of my friends, I've just decided to limit the number of industries I'm exposed to so that I won't know these details about too many things. It's all a completely irrelevant anecdote, but it does have to do with skepticism. So some important disclaimers. All the numbers in this presentation are made up. The stories are true. I have filed names and numbers off them, but I personally was involved in them. I am not a statistician. I really do not in any way resemble a statistician, which is a bit dangerous because I'm about to talk about statistics. And I'm done with the funky transitions now. That was funny, but we're over it. Few assumptions about the audience. I'm assuming you are system administrators, which means, number one, I'm assuming you are also not statisticians. If you are a statistician, or you do research for a living, try to just zone out when I talk too much about numbers. I'm attempting not to lie, but the accuracy is, yeah. I'm also assuming that most of the data you're collecting is about machines. Computers, networks, packets, mail messages, things that do not have ethics boards. We will be talking briefly about humans, but mostly about computers. Computers are easy. All right, so this is the one slide summary for those of you who plan to fall asleep very rapidly. Numbers are good. We like numbers. Believing appearances is bad. We don't like that. Making stuff up, sometimes perfectly okay. So when I talk about being a skeptic, when I talk about searching for data or truth or whatever, what am I talking about? I'm talking about an attitude, a way of looking at the world. one of the things you notice is that good system administrators, good security people tend to have in common this attitude. It's also a fascinating hobby. Well, you don't mind if you, well, it is, I admit, a little geeky as a hobby. And it's where science, system administration, and security overlap. And it looks something like this. That's interesting. I wonder what I could find out about it. And it requires the ability to distinguish between what things look at and what they really are, and to understand numbers. So, story about appearance versus reality. I used to work at a security company. We had a couple of guys who could pick locks. There wasn't any real reason they could pick locks. It's just that geeks tend to have geeky hobbies. And what really annoyed them was not so much that there was very little call in their life for picking locks, but it was that people kept coming by and saying, oh, gee, I know you know all this technical lock-picking stuff. Could you unlock this for me? When the answer was, dude, a bobby pin, 5 seconds. This is not interesting. Or in this case, that's a standard locking file cabinet. That's its lock next to it. Looking at the lock, you might already begin to feel a little uncertain about this entire operation. It's a big file cabinet. It's a little lock. It's got a little tiny thing sticking up. You don't really need to unlock file cabinets. If somebody comes to you with one of these cabinets, which did happen to us, somebody came by and said, we have this file cabinet. We think it's ours, but it might have come with the office when we moved in. We're not really sure. And in any case, nobody's really sure what's in it, and we certainly don't have any keys for it. Could you unlock it? And Drew says, why? And they say, well, because we're about to move everything, and it would be, your file cabinet's heavy, not worth moving if it's paperwork the last guys didn't like enough to take with them. He said, but, the only thing that keeps these things locked is gravity. So if it's your file cabinet and you're going to move the thing anyway, just tip it over and open it. So we did. It was ours. We moved all the data to a file cabinet we knew how to unlock. Then the CFO says, oh, could you break into my office for me? He says, I could, but that's not really a lock-picking problem either. And she says, excuse me? And he says, do you have a chair and a coat hanger? And she says, yeah. And he unfolds the coat hanger, stands on the chair, lifts up the raised floor tile, hooks the inside door handle with the coat hanger, opens her door with a flourish, and says, there you go. And she says, of course, I'm not sure I wanted to know that. It looks like a wall, but if it stops where the ceiling begins, it's not really a wall. That's appearance versus reality. And that's where you learn to start getting skeptical of things you always thought were solid, like walls. Numbers are your friend. This is another story back from the ancient days of history when I was a starving college student, living with another starving college student and a slightly less starving computer consultant. We were actually all computer consultants, but he did, the exciting stuff, like really writing programs. And my starving college student roommate had just bought a book on algorithms, which had not gone over very well with my computer consultant roommate, who thought it was an absurd amount of money to spend to find out different ways of doing things he already knew how to do. Where does pizza come into this? Well, one night we go and we said, hey, we're about to go out, have a pizza, see a movie. Do you want to come with us? So he says, nah, I'm not going to make it for the pizza. I have this 30,000 item linked list of the customers. All the links have gone, and I'm rebuilding the linked list. I think I can make the movie, but I'm never going to make the pizza. And we kind of look at him for a while, and we say, so what sort algorithm are you using? And he said, I don't know what you're talking about with this sort algorithm and stuff. I'm just going down them until I find the place it belongs and sticking the thing in. And we look at him for another long minute. Yes, some of you are already going, order n squared. And my friend says, so these things, were they by any chance already in order when they were entered? But computer consultant says, why, yes, somebody hand-entered a pre-existing database for almost all but the last 1,000 at the end. And we pull out calculators and we start calculating order n squared. This is Saturday night. My starving friend says, so when are you delivering this? My computer consultant friend says, why do you want to know? 9 o'clock Monday morning. He says, well, because by my calculations, it ain't going to finish until about noon on Monday. So, you might as well come eat the pizza. No, that could never happen. We saw him Monday night. He was triumphant. You were completely wrong. It finished at 3 a.m., made it to the client just fine. And about sort algorithms, you were saying there are different ways of doing this. Numbers are your friends because when you know what it means for an algorithm to be order n squared, and when you know what worst case means, you do not attempt to insertion sort pre-ordered data and still, finish in time to catch a movie. So, assuming that, I haven't already convinced you that numbers are your friend, why might you personally care? Worrying about numbers, worrying about data is your best chance of avoiding system changes and system upgrades turning into sucking nightmares as you run into whatever the equivalent of order n squared is. For instance, as you run into the more mailboxes there are, the longer it takes the system to add a mailbox, because I'm sorry, my computer consultant friend is not the only person in the world who does not know how to design software, and many of them work for large, important companies. Looking at data, looking at the innards of things is also part of troubleshooting. It's part of being good at security, and I think it's just plain fun. It's also part of not falling for pseudoscience. Data makes bad news. Therefore, most news items about data, which say things like, oh my God, you're all going to have swine flu, are just unutterably bad. So bad that a person who knows 5 facts about statistics can look at it and go, I don't think that's real. So when you come to look at things that look kind of data-ish, there are 3 important questions. Is this data? What is it data about? And what conclusions can we draw from it? So is this data? The CEO says the network is slow. Is this data? Yes, no? No, not data. Not data for any number of reasons. We'll get to one of them later. 47 users complained about network slowness yesterday. I like this one. I say this one is data. I'm not sure it's data about the network, but I think it's probably data about something. Average network latency yesterday was 15 milliseconds. Data? Not data. Not data. I'll explain to you why I don't like it later, but it's a number. It's a random number. I don't know anything based on it. I feel like something might be wrong with a core router. Now, okay, again, I like going against the flow. I think this one is data. If you have been a networking engineer all your life and you think something is wrong with the core router, I think that's data. I'm not convinced there's something wrong with the core router, but I'm willing to put it on the a data point leading me somewhere path. Brand A's router has an error rate 200% worse than brand B. Okay, just because I like numbers doesn't mean I like all numbers. I don't like this one. It's bad. Sites that use brand A's router report slowness more often. I don't like that. Wait, I'm looking at the wrong one. Sites that use brand A's router report slowness more often. I don't like that one either. And it's not because it doesn't have numbers in it. Okay, any votes for we didn't change anything around the time people... That's pretty good. That one's not even data. That's not only not even data, it's funny. Yeah.
It's certainly false.
It is certainly false. Now, there's a subtle distinction here. Some people would say this is a lie. Now, remember, we're talking fiction here. You all do not know who said this and in what situation, and you're already sure they're lying. Okay, me, I believe they're wrong, but I don't believe they're lying. I believe they are deluded. It's an important distinction. We changed the routing just before people started complaining about the network. That, I think, is data, and it's data about as good as I think the core router is broken. That is, it's a data point. You can put it in the pile of data and see what comes out the other end. People are complaining because you changed the routing. Not data, go away. So what do I consider not data? Hearsay. That is something you say somebody else said. Take it away, it's not data. Numbers without context. As I said, I like numbers. I'm just a little discriminating about which ones I'm friends with. And conclusions. You know, don't tell me why, tell me what. Things I think are data, observations, something you saw, self-report, something you are telling me about you personally, and numbers with some context. So what do I mean by hearsay? One of my data gathering hobbies at one company, I had a CEO I got along well with, and I used to go into his office and say, I heard that you said blah. Is that true? Now, this is a trick you can only get away with if A, you know the CEO, and B, you phrase it something like that. I wasn't tattling on people. I was just curious. And I got a lot of interesting answers that way. Sometimes I got, yes, I did say that. Let me tell you why. Sometimes I got, no, I didn't say that. Let me tell you why. Once I got, what kind of an idiot would say that? To which I said, that was going to be my follow-up question, but I wasn't planning on phrasing it quite that way. And once I asked the question, I hear that you said that it is very important for operators on the graveyard shift to wear uniform shoes, to which I got the classic answer, no, I didn't, and I think the red patent leather Doc Martens are actually pretty charming. Okay, so I no longer accept any argument of the form the CEO said blah. I certainly don't accept it about the network because I've never had a CEO who would know whether or not the network was slow for any reason other than somebody told him. And number two, because most of the people who tell me what the CEO thinks are making it up just as much as the ones who tell me they didn't change anything just before it broke. All right, so I showed you a bunch of numbers I hated. I said they're not data, I don't like them. Why aren't they data? So here's some basic statistical skepticism. If you don't know anything about statistics, you can still worry about numbers. What do you mean average is your first question, compared to what is your second, and what do you mean correlated is your third? So here's a graph. It's a graph of total bogosity. I told you I made the numbers up. We can tell a couple of things from this. First of all, well, the first thing we can tell is that I made the numbers up, because it's a completely symmetrical graph with really small integer numbers on it. So either I made these up or God is interfering with my experimental results. Allowing for that, we can tell something else. Is this a graph of the average size of the files on the network? Anybody? No, it's not. You can tell that without actually knowing anything else. This is a graph that has something to do with a large population that varies in more or less small random directions. It is characteristic of the kind of graph you get if you measure stuff about people. It's probably characteristic of the kind of graph you get if you measure stuff about sea anemones too, but I don't deal with those. So I look at this, I think this is probably a graph about people. It has another interesting characteristic. That's the average. I don't care what average we're talking about, that's it, smack in the middle there. That's interesting because here's another graph, more made-up data. This is a graph that looks like graphs that you will see more often. Okay, if you are measuring things about computers, you basically never see a nice symmetrical single humped curve like that. You see things that look like this. I don't know of a name for this distribution. If you are really geeky, it may remind you of a Poisson curve, but it isn't one. But it looks kind of like this. There's a peak, it's small, there's a bunch of kind of middle-sized stuff, and there's an outlier. There's the median. The median is an average. If you lined up all your data points standing next to each other, the median would be one in the middle. Half the data points are to the right, half the data points to the left. That's the mean, that's the average you always heard of before, where you add them all together and divide up by how many there are. And in this curve, they're not lined up anymore, and they're not at the top. There's another one, it's called the mode, nobody cares, move on. I told you I'm not a statistician. You really only care about the mode if there's more than one of them. So mean, median, they're pretty close here. Here I have another curve, just as bogus, except I have moved. Actually, it's an even worse graph, because you notice the numbers don't go all the way up to 100 because I'm lazy. The outlier has moved out, right? It used to be at 10, now it's at 100. The median hasn't moved at all. It's still sitting exactly where it was before, plus or minus a pixel because it doesn't want to line up in the middle of 3. The mean has scooted over here. What does that mean? It means the mean is not telling you a lot. It's not telling you where the peak of the curve is. It isn't telling you where the halfway point is. It's not telling you much of anything. And if that outlier there at 100, that's the guy who uses your printer to print off 47 copies of every manual he's ever gotten, right? He's just going to keep being an outlier. He's just going to go further and further out there, and the further he gets, the more meaningless the mean is going to get. It's going to scooch right out there until it gets into the flat bit where there are no data points. So when somebody says average, 90% of the time they mean mean. Means are only interested for symmetrical single-peaked curves, like that first one, things about people, sea anemones, big populations that vary kind of randomly. Your data, if you are looking about things about computers, probably not that kind of curve. Thus, you want a median. If you extend the median out and you start taking, quarter points instead of half points or 10th points or 100th points, you get quartiles and percentiles. You like medians, you like quartiles, you like percentiles. You don't like means. And if somebody just says average, you have no way of knowing what number they're feeding you or what the distribution looks like. If you do want a mean, you want a standard deviation. What is a standard deviation? Well, if you have one of those beautiful camel hump curves, it tells you how pointy the curve is. What does it do if you have, a curve like the curves you've actually got? Nothing, except that it tends to give you a good hint that you're not being useful. So what can you do when somebody says the average is? Number one, tell them to go away and come back with a picture of what all the numbers are. That would be your first best move. Failing that, ask what kind of average it is, and if they say, what do you mean, what kind of average? Laughing at them while desirable is not probably an appropriate response. But certainly don't take their word for anything involving numbers. If they can tell you what kind of an average is, and it's a mean, or if you just want to keep seeing if there's actually any data behind this number, ask them what the standard deviation is. If the standard deviation is bigger than the mean, you have empirically determined that the mean is worthless, and it is now time to move on. Note that the number of people who will tell you the mean and the standard deviation when the mean is 156 and the standard deviation is 257 is non-null. And many of them do not know that they are speaking nonsense. So we had another one where I said, it's 200% faster. I said, no, you got to tell me compared to what? Why? Is 99.9% accuracy good or bad? I don't know. I work for Yahoo at the moment. I get more evil packets in an hour than you probably get packets in a day. It's just a statistical guess, but for most of you, it's true. So 99.9% accuracy is just the worst thing I ever heard for something that's attempting to determine badness on network packets. Probably no one in this room has a network so small that they could stand listening to that go beep. And as for accuracy rates, and does anybody out here actually use Yahoo? Okay, I have a follow-up question. Have you ever seen an error 999? No, it's pretty good. We have, I don't know what our error rate is on that. We have a false positive rate on that that has to be better than 1 in 10 million. And we still generate false positives on a fairly regular basis. So 99.9% accuracy, I don't want to know unless you tell me per what. As for false negative rates, I'd be pretty happy with 99.9% accuracy. I'm not going to get 100. There's not that much evil stuff out there. Well, I personally wouldn't. Because, again, I get more evil packets than most people get packets. But most sites could put up with a pretty high false negative rate and still catch most of what they're going to catch. But for a false positive rate on anything that tries to alarm per connection, per packet, your head's going to explode at 99%. So the number itself means nothing. Okay. How about a 200% increase in error rate? Sounds bad. If my risk of being hit by a meteor increases by 200%, I'm really good with that. If my risk of being in a car accident increases by 200%, I am not really good with that. Because if your initial error rate was 1 in 4, your new error rate is 3 in 4. That goes from unacceptable to, I don't know, probably fatal. If your initial error rate was 1 in a million, your new error rate is 3 in a million. Again, depends on a million what. People think millions is a big number. They aren't really, but if 1 in a million didn't bother you, 3 in a million probably ain't gonna either. All right, one last reason why I don't particularly care what your error rate is without knowing 400 other things. Suppose we have router A and router B, and they have the same error rate. And one of them eats randomly pretty much every millionth packet. And the other eats every packet of a type that comes up fairly rarely. They both have the same error rate, but one of them is much better than the other for my situation. Without knowing whether or not I use those rare packets, I can't tell you which one it is. But I know that one of them will be better. If I never use those packets, then I want the one that eats them. And if I do use those packets, I'd prefer for you to eat every millionth one randomly. That's going to get lost in the noise. Far worse things happen on the internet every day. So, talk a little bit about correlations. That's what I had here with sites that use brand A routers are more likely to report slowness. Mostly I'm being uncontroversial here. So we have, unbrand router names. Correlation does not imply causation. What does that mean? Because statisticians say that a lot. For all I know, they write it down on cards and randomly hand it out to people. The temptation is large. What it means is, suppose it is true that sites that use brand A routers are more likely to report slowness. There are a lot of ways that you can get there. For instance, it could be that, say, 400 of our reports of horrible networks come from sites that use brand A routers, and 100 of them come from sites that use brand B routers. because brand A router has 10 times the market share of brand B. Thus, more people complain about it because more people own it. In that case, it's far more likely that brand A is actually a better router. Some correlations are weak. We'll get to that in a minute. This does not come up often in technology, but if you look at enough correlations, some of them will be strong. If I get to look at every possible thing that could ever correlate with, say, your choice of operating system, something bad will correlate statistically significantly to your favorite operating system. And it will correlate to any degree of believability that you would like to pick, as long as I get to look at all of them. It's just a law of large random numbers. So if somebody sets out to prove a hypothesis and they say, well, I was looking for this, and I checked it out and it proved out, that makes sense. But if they were just trolling around for bad stuff, they're going to find bad stuff. All right. Here we have, once again, some curves about which we can tell two things. One, they're fake, and two, they look kind of like human populations. In this case, being green is correlated with leftness, and being purple is correlated with rightness. And if I just tell you green things, whatever, my left and my right, switch the directions. Being green is correlated with being next to that wall, and being purple is correlated with being next to that wall. And if I tell you that green things are more likely to be over there, you're going to imagine something that looks a lot like this. There's some overlap there, but most of the green stuff is over there, and most of the purple stuff is over there. Mathematically speaking, this is also a perfectly good depiction of green stuff is more likely to be over there, purple stuff is more likely to be over here. The thing here is these curves overlap. They overlap over most of their area. If you randomly pick a green thing and a purple thing, the green thing might be to that side of the purple thing, or it might not. There's just, your odds are certainly skewed, but they're by no means vastly skewed. And another small side diversion into science in general, when somebody says group of humans A is more whatever than group of humans blah, this is the diagram you should be picturing. They all look like this. For instance, if I say to you, men's voices are usually lower than women's. This is a fairly non-political statement. It is indubitably true, and the curves look like this, right? There are a lot, myself, I'm a relatively low tenor. I sang second alto in school. I was lower than a lot of the guys. There's another thing you know when people give you these numbers about humans. You know the curves overlap by a lot, and you know that it is also culturally determined. The difference in pitch between men and women is larger in Japanese than it is in English. You would think it was a fact about biology. It is a fact about biology, but it is also heavily culturally determined. And if that's true about relatively uncontroversial things like voice pitch, you can bet it's true about every other statistic people are giving you about category of humans A and category of humans B who differ on this parameter randomly chosen. It's also, of course, true of the routers and the everything else. When people say it's better, they usually mean you can find the difference between the peaks and the curves, and sometimes they mean only if you use a magnifying glass. Okay, so that's a basic course on how to tell numbers that look vaguely like data from numbers that actually have some hope of being data. And my three original questions.
Did you know that 89.3% of all statistics are made up on the fly?
Indeed, and I even told you I was making them up. So there's a brief introduction to things that look like data but aren't, things that don't look like data but maybe are. The next question is, if it is data, what is it about? 47 users complained about network slowness yesterday. That's probably real data. You could probably track down those 47 users. It's probably not real data about the network. It could be, it couldn't be, no way of knowing without finding out. It's real data about users. I was working at Silicon Graphics at one point. They announced a big router change. The engineers all worked until 3 o'clock in the morning, then they went home. When they got in at about 10, there's a big discussion going on. About half the users were saying that the network upgrade was terrible. It had made their performance much worse. There were another small but devoted set of people saying, no, 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 performance was much better. And the engineers regarded this in sort of appalled horror. And then they sent out the mail saying, well, we tried until 3 o'clock, but we couldn't actually get the replacement routers to work. So we canceled the network upgrade, and by then it was 3 o'clock in the morning, so we forgot to send out the notification. In fact, your network is exactly the same as it was yesterday. We did not actually so much as unplug anything from the existing network. We spent all our time in a test lab determining that, in fact, the routers were DOA and there was no way to actually do the change. And undoubtedly, yeah, some people were seeing slower performance than the day before. Some people were seeing faster performance than the day before. Stuff varies. So the people complaining is real data about users. Network usage is increasing rapidly. Probably real data. What does it mean? More made-up data. OK, so here we have users and network usage. This data is made up after the pattern of data from an ISP, actually not in the United States. 30 users, 60 whatevers of network usage. Ooh, look, users go up. Network usage is twice number of users. September, October. Oh, we've gotten a little better at selling things. Network usage is a little more than twice the number of users. November. Oh, we've gotten even better at selling things. Network usage is a little more than the multiplier it was in October. Oh, there's December. That's not a fun month, is it? In December, great, we got 40 more users. We were kind of expecting that. But the users quadrupled their usage. And we really weren't kind of expecting that. That doesn't look like the curve we were on before. Welcome to Christmas. Welcome to Christmas when you don't want to be running an ISP. There are 2 reasons you don't want to be. We're going to get to the next reason you don't want to run an ISP over Christmas shortly. They can't quite return their ISP service. So in December, we sold a whole lot of usage accounts. And in January, woohoo, we're back to more or less normal network usage. So our network usage is, even though our number of users has gone up, our network usage has dropped slightly because the multiplier is better. Oh, February. February is a really good month to be a network engineer and a really bad month to be a sales engineer because we hardly got any new users. That's because December is a really sucky month to be an ISP because you have everybody who got new accounts for Christmas presents trying to activate them while your staff is on vacation. So by January, the rumor has gotten around that you don't have enough network and your user service sucks, so you don't sell a lot in January. That's interesting. Here's the line that your naive people start predicting around about August. It's got a nice, slow, linear increase in the number of users. Fortunately, you weren't on that line. That line, you go out of business. Here's the line the marketing people were predicting. You more or less were on that line. That was good for a while, except the marketing people didn't know about that multiplier in December. That one has a knee in it. You've kind of missed the knee. That's probably not good for your long-term survival either. But that was a much closer curve. The difference between those lines is the difference in what people think those numbers mean. And round about November, people are spending a lot of time arguing about what those numbers mean. You could have a month like this. This is pretty much the same chart. It's got the same multipliers, but somehow you managed to survive December. You pre-allocated the network space. You actually didn't let your user support people go on vacation. You were still selling at a good rate. The network people are beginning to feel worried again. They survived December, but things are looking tight. And this is the curve the marketing people were hoping for, in which we went from 180 users in December to 280 to January to 560 in February. The marketing people are very happy. The network people are not, because they have just, once again, run out of network space. The differences between these numbers are all differences that fall in the December and January time frame. You're trying to decide what those numbers are about. Are those sales figures because we are really doing great and people love us and we are going to sell lots more? Or are those sales figures because we put ads up on the sides of buses all December and they're all going to go away in January? Without knowing what the numbers are about, you can't make the prediction that allows you to figure out how much network you need. Most data is about lots of things at the same time. The users are complaining that it's slow because it's slower. Could be your network. The users are complaining that it's slow because they changed applications. The users are complaining that it's slow because they don't get any raises this year and they're just pissed off. Those are all possible reasons, and without knowing what the data is about, just knowing that the users are complaining that it's slow doesn't tell you much. Once again, fairly early in my career, I ran a university computing network, and I got an immense amount of flack around hiring issues. Why was that? That was because of two sets of numbers, one that was widely publicly visible and one that wasn't. The publicly visible one was the campus computer science department employed 9 black employees. I had 8 of them working for me. I did not have a particularly large group. I had, say, 1/5 of all the employees in the department. So this was a sort of striking and visible ratio, which was widely interpreted as being evidence that I was pushing a political agenda. Now, there was another set of numbers that people didn't know about. If you went and looked at the hiring data, and I was continuously afraid the university would, race was coded on the applications when people were willing to check it. And you could see that, in fact, white applicants were much more liable to get hired than black applicants. That is, if you applied for this job and you were black, you had about a 1 in 5 chance of getting it. If you applied for this job and you were white, you had about a 1 in 2 chance of getting it. Now, if you've dealt with student numbers, these are kind of funky numbers to begin with. It tells you we really didn't advertise these jobs much. Both of these numbers, so one of these numbers leads you to the conclusion that I am out there attempting to single-handedly right the racial discrimination problems of the university. And the other leads you to believe that, in fact, I am skewing my hiring completely in the other direction. Both of these numbers derive from the same fact. They derived from one person who wasn't me, and they derived from the fact that every black student in computer science had applied for a job with me. Absolutely, without exception, every one of them. Because there was somebody who had looked at these jobs, realized that they were not widely advertised, realized that they were, in fact, an excellent route to getting a job after graduation, and gone out and sought out every black computer science student and sent them to apply for one of these jobs. We only gave jobs to people who were sophomores and below. So a large number of applicants got ruled out instantaneously, and thus you got a paper hiring situation in which I was radically out of tune with university imperatives, and an actual hiring situation in which I was very visibly in trouble for my strange plot to hire minorities. That's a difference in what the data is really about. When you know where the data is coming from, the picture changes. So to be fair, I said, once you know whether or not it's data and what it's data about, the next thing you want to know is what conclusions you can draw from it. There is basically nothing of general application you can say about this. I can encourage paranoia. From what I've shown you, you know that either, if you are an ISP, either your network is massively over-provisioned most of the year, or December is really unpleasant. In general, it's important to remember that data is a lot easier to find than truth. That you need to be cautious in your conclusions, and did I mention correlation does not imply causation. Third graders are taller than first graders, but promoting your child to third grade will not make them taller. Okay, so I have been somewhere out in the extremely abstract stratosphere. I'm not an atmosphere scientist either, but I'm going to move, a couple layers closer to actual Earth as we know it. Yeah, so suppose that you wish to go out on a search for data. What do you need? You need a programming language, preferably one that's good with text. I told you I wasn't going to be political. I don't care what programming language it is. You need some programs for looking at the guts of things. And I'll get a little bit more on that. And you need some programs for making data into pictures. Looking at guts of things, by that I mean, you're probably going to need something like trace or dtrace or truss or whatever your operating system has that lets you look at exactly what your programs are doing. You're probably going to want something that lets you look at packets, sysinternals if you're on Windows, Wireshark, TCP dump. Whatever programming language you like probably has a profiler. At some point, you're going to want that. What can I say? I make data, well, these horrible made-up data, those I made into pictures with Keynote. We'll see just how bad that can get in a while. But normally, I'm afraid I use Excel. Except when I use GraphViz for things that just require stringing boxes together. GraphViz is excellent. You should check it out if you want to chart things that are not XY charts. Sorry. GNUplot. GNUplot will make your diagrams horrible in a way that is completely unlike the way Excel makes them horrible. Basic knowledge, you're going to need to know regular expressions at some point. You will probably need some SQL. It's not that hard. You probably need some XML. That's just verbose. It's not hard either. And you will need some basic statistics. I feel kind of funny about all this, love of numbers stuff. I actually got into computers because I was looking for a way to pass my math requirement without having to actually do math. Because all of the math that I would have had to do in the math department involved 1,000-person lecture classes. That's not one of my better skills. So I took programming and, as it turns out, statistics instead. And that seems to have been a pretty good choice. It worked out for me. But basic statistics are not that hard. So when you go out to find data, what are you going to do? Well, you have some choices. Step one is to look for data that's just lying around. mining existing sources. Step 2, you can cause new data to come to be. You can simulate and or extrapolate. We just saw extrapolation, very dangerous, but sometimes you have to do it anyway. You can find somebody else with data. That's always fun. Or in fact, you can make stuff up. I will justify making stuff up in a minute. Mine existing data. How many files have we got? Count them. I actually went out and did this once. I got into an argument with someone about backup systems. And he said, there's a 1 in a million chance of that happening. I said, 1 in a million what? And he said, files, 1 in a million files. Okay. How many files do we put on a backup tape? Let me go check. Ooh, look, 800,000. This was not as long ago as some of these, but still pretty long ago. I said, so you mean it happens about 5 times a week? He said, no, that's not what I mean. I must not have meant 1 in a million files. And I said, oh, how about I just pull up some backup tapes and count? So I pull up some backup tapes and count. And you know what? He was right. As random happenstance, it really didn't happen all that often. However, it happened about 6 times a day systematically. Plus, it turned out something I hadn't known before. If I went and read the tapes and I checked to see, how many tapes actually read a directory of the data without whining, 0. All of them whined. Sometimes about really important stuff, like, whoops, there was a whole bit of that tape I couldn't read. Hope you didn't want those files. And sometimes about things like, gee, I thought there were going to be 2 links to that, and there were really 3. But it was extraordinarily depressing, and no one had ever gone and done it before. What are people's names like? Look them up. Here I am at a large company. I am working in Europe. They are redoing their sales tools. The team that is redoing the sales tools is located in the US. And they have an 8-character username. So they come up with a lovely theory. And their lovely theory is, we will give you the first initial of your name and the first 6 characters of your last name. And that leaves us a whole digit to use for disambiguation if there are any that are the same. And it'll all be great. And I said, so how well does that work? They said, it'll be great. Said, look, we have an employee database. SQL, select first name, comma, last name from blah, 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 pipe, sort, unique -c, pipe, sort, -n. Ooh, look, the top number starts with 14. For those of you who can't follow Unix command lines while I'm kind of waving my hands around, what I did, I went to the employee database, which anybody could do. It was the phone directory, pulled the first name, pulled the last name, glued together the first 6 characters and initial, sorted them into order, had unique -c count up how many of them were the same, and sorted it so that the biggest number rose to the top. Why would I think to do this? Well, if you're Dutch, the chances are pretty good that your last name might begin Van Den or Van Der. And if you are Dutch, and you are going to start the first 6 characters of your last name, you're going to ignore that. That's going to be cool. You're just going to chop those off. If you are American and you are looking at a whole bunch of people named Jan Van Den something, you're going to cut off the whole interesting part of their name and replace it with of thee. And then you are going to be highly surprised to discover that half our office is named J. Van Den or J. Van Der with a number after it. Now, the nice part about this story is that after I handed it, and it didn't actually work in the US either. I don't think any of the J. Smith 7s were going to, J. Smith 7, J. Smith 8, and trust me, D. Farmer 2, not a happy person. But that's an entirely different story. But in any case, It was not particularly hard. It was on the order of 3.5 minutes of work to actually take this algorithm, turn it into something one could call code, and spit out an answer to the question, does this actually fit into 8 character spaces once all is said and done? And the answer was no, and I won that one, which was a glorious surprise. They went away and said, no, we're not going to do that. Perhaps we will just let people pick their own usernames. Ooh, wait, look, they all have Unix usernames, which, surprise, are 8 characters long. So, more on mining existing data. Those log files might be good for something. I'm sure all of you love your log files. There are many sites out there whose log files are primarily used as a way of exercising an otherwise idle disk. So when you go out looking for data, log files are always an interesting place to look. You know, I used to work for a company that had a security product based on syslog, and we used to sign people up, and about 10% of the time, we would sign up a new customer, and we would call them up and say, could you do us a favor? Could you either fix that router or turn it off? And they would say, what router? We'd say, well, you know, you have a router whose second CPU has been failed for I don't know how long. But, you know, it's just whining at me every 15 seconds. Excuse me, did you know my second CPU, it's dead? And, you know, either unplug the thing or shut it up or something, because your log files are full of perfectly useful and fascinating error messages that you are ignoring. Suppose you have gone out and looked at the available data, and it's not getting you there. You wish to actually collect new data. You can add logging. That's going to come up a lot. You can end up saving snapshots of changing data. If you want to answer questions about backups, you're often going to count how many files changed today, how many files changed yesterday. You can actually run tests. This is fun. This is another, you start pulling on a loose end and the whole sweater falls apart. One day, once again, staring at backups, it occurred to me to wonder what the CPIO man page meant when it said that if a directory had too many links in it, it wouldn't back it up. And after that, I built a program that did horrible things to file systems. And I was really only trying to figure out, you know, what made CPIO blow up. And I found a bug. I found a very old bug. I found a bug so old that it ended up occurring in both AT&T Unix and BSD Unix, because it dated back to the days before that. Various luminaries of Unix spent a while arguing about whose bug it was. It was a I think their result was not Steve Johnson, but it could well have been either Kernighan or Ritchie. There is an old programming saying, don't check for error conditions you don't know what to do with. The original author of SSCK failed to follow this advice. And given a path that was longer than max pathlen, and I won't go into how that can happen, but it's easy and you can do it as a normal user on most systems, FSCK would exit. It would go, I have no idea what to do, I'm just going to exit. And then your file system would be unclean, and you would be unable to mount it. And I was kind of testing on random file systems owned by friends across the United States when people started calling me up and saying things like, say, were you done with that machine? Because it doesn't boot anymore. Probably it would be a good idea not to do that, but it is certainly a way to discover who your friends are. They're all still speaking to me. But at least one of them did file a priority 1 operating system against his bug against his employer's operating system. Simulation and extrapolation. Set up a test situation, find a similar situation, go back to digging up data. Find other people with data. This is very good. This is just like academic research, right? You go out and look and see who you can borrow data from. Yeah, other people's data not necessarily any better than yours. Get it as raw as it comes and know as much about it as possible. So why would I advise you to make stuff up? Well, because I've been known to work at startups. And startups do a lot of stuff where nobody knows. I mean, if there is data out there, it's all owned by your competitors who don't feel like telling it to you. So you probably just don't know. And so you're trying to design a system. Somebody says to you, I need a computer system that will support our service 9 months from now. Great, you say. What are the transaction volumes? And it's just like being back at Rockwell International. I don't know, they say. Lots, I hope. Could you define lots for me? Then, and it's another great game, you go to everybody in the company, you can do that at a startup, and you get each of them to tell you how many transactions will be happening. The last time I tried this, I had a low of 1 a day and a high of 100,000 a minute. And I will point out that I did not scope the system for either of these estimates. Also, we had a long chat with the sales guy who thought the answer might be 1 a day about exactly how the system worked. So that is actually a good way to start. Get everybody to tell you what their guess is and what they're basing it on. Base it on the knowns as much as possible. In the same scoping exercise, I had someone say, well, you know, the resulting system doesn't scale far enough. And I said, well, how far does it scale? And I told him, and he told me, and I said, well, you know, at the point where it runs out of scale, this company is larger than McDonald's. And at that point, I will have moved on. I think we can cope with that. Right now, we have a customer. When we have 5 million, I'll worry about whether or not we can get to 10. So there's a lot of that scaling going on. So what do I mean by this? Suppose you want to know how much data a given backup scheme will back up. How many tapes do I buy? Surprisingly, most people answer this by pulling a number out of the sky and buying random tapes. You can pull data from the existing backup system, educational, depressing. You can, often you're going to actually change your theory of how often you back things up. It's worth recording statistics by day. Go out and look at which files have changed, which files you would have backed up. You can also do simulation, which is a really elaborate form of guessing. You have a theory about how often people change their data and see what it looks like. My current deal, I'm supposed to replace a website about educating users on security with a better one. So of course, I went out looking for data. That was a surprise for most people I deal with. So first I went off to look at the logs of existing stuff. What do we have now that people look at or read? What are they searching for? Eventually I'll go out and do some collection. When I have some content to put in front of people, I'll go out and ask them questions. And I did some research. I went out and found other people's data. There is some interesting data. Most of it is not directly related, but I like data anyway. So not everything you care about is a machine. Some of them are people. They have opinions. Human subjects boards. If you are going to collect data about people, and you are anywhere that collects data about people, there will be a human subjects board to deal with. And, you know, I spend most of my time in experiments where you spend a lot of time looking at the human subjects boards forms and going, possible negative outcomes. Dude, I'm asking them to fill out a survey. They could be terminally bored for several minutes. Yo, it's on a screen. There aren't even any paper cuts. I think we may have listed actually learning algebra as a possible negative outcome. Nonetheless, particularly if you're dealing it is worth thinking about this stuff. And particularly if you are in a university or you are attempting to publish research or deal with the federal government, find out about the Human Subjects Board, comply with their requirements. Someday it will save you from unethical people. Aside from that, random sampling is good. Computers, most of the things we deal with on computers are kind of like each other. People are not very like each other. And they differ in lots of ways. And I will talk about random sampling and sampling bias again in a little bit. Random sampling is very difficult, particularly when you're doing things like getting users to fill out surveys. It would be kind of fun if I could actually force everybody who looks at my website. Well, I think, as the owner of a website, that it would be fun if I could actually force people who went to it to fill out a survey. As a website user, of course, I say screw this and move on most of the time, just like everybody else. Random sampling of your customers as a system administrator is extremely difficult to achieve. So what do you do if you can't be right? And by the way, unless there is a psychometrician hiding in the audience, probably if you set out to ask people questions, you will do it badly. So what are your options? Option number one, numbers that don't mean anything aren't data just because they're numbers. So if you are not going to be able to design a good quiz and administer it to a largish random sampling of people, you might be better sitting in a small room with people and asking them what they think. The resulting data is what they call qualitative. It doesn't look like data much. But it is considerably more valuable than a number that looks like data but is biased in 27 different directions. Failing that, be wrong as many different ways as possible in the hope that they will all cancel each other out. So what do you do if you are a system administrator and you want to administer a survey and about all you know about writing an unbiased survey is it's hard and nobody ever taught you to do it? What you do is you write 4 times as many questions as you need. You put them in a random order, you put the answers in a random order, and you hope that in the end, you will have been wrong as many ways as possible and they will cancel each other out. Failing all of those, at least figure out what exactly is wrong. And now that I think about it, I don't like this ordering, but I'm going to go with it anyway because it's there. We are going to come back to human subjects in a bit. So once you have a pile of data, what do you do with the data? Well, maybe fascinating things will just jump out at you. That may sound awfully optimistic for somebody who's supposed to be a skeptic, but it happens a lot. Maybe you just need to figure out why the data is that way. Maybe you're actually going to analyze it. I have 25 minutes left if you don't ask any questions, and I am not going to teach you data analysis. Why do I say maybe interesting things will just leap out at you? Well, I wanted to learn SNMP. It so happens that the most interesting variables anything I had would give me was the temperature. It's more interesting than the number of packets. Also, I have a better grasp of whether I'm actually successfully getting the right answer than if I ask a router how many packets have gone through. So as an SNMP test, I start asking random routers what temperature they are. And as it happens, I'm in Switzerland, and the routers that we have close to us don't know what temperature they are. But that's OK, because there's a router in the US that's perfectly happy to tell me its temperature, which is really startlingly cold, but whatever. So I go home. I come back. I do it again in the morning. In the morning, oh no, it is not really startlingly cold. It is impossibly cold. It is, in fact, 11. This is not a happy number. So I go look up the documentation and discover that, in fact, the router is reporting its temperature in Celsius, which is okay. I like 11. I don't like 50 in Celsius. That's not a good number at all. You can see, just for those of you who don't know Celsius, there's a handy thermometer here. That's a little over 120. So if I thought 50 was cool, I really don't think 120 is a good temperature for the router to be. So I spend a while worrying about whether actually I'm incompetent with SNMP and contemplating whether it is possible for the router to sometimes speak to me in Fahrenheit and sometimes speak to me in Celsius. And 3 days later, I call up a guy in the US and say, I have 2 really important facts you need to know. And he says, who are you? Yeah, well, it's a long story, but anyway, I've been asking your routers what temperature they are for the hell of it, and just go with it, because I have 2 really important facts you need to know. And because that was kind of what SGI was like, he said, okay, whatever. And I said, so the first thing you need to know is that your machine room is on building air. And as soon as you go home, all the air conditioning goes off. And then it gets really, really hot. Oh, so terribly, horribly hot. And he says, oh, that couldn't possibly happen because I have alarms set. And I say, and the second thing you really need to know is that it's reporting the temperature in Celsius, and your alarms are going to go off at about the time the machine actually catches fire and melts. Your first over-temperature alarm is set at a really good temperature for making tea. Not at a good temperature. And he said, wow, gee, gosh, that does explain the unexpected disk mortality in that machine room, doesn't it? So what you have here is not so much a machine room as a baking test lab. So when I say, maybe you just look at the data and something leaps out at you, I wasn't even actually collecting data. I was merely trying to figure out whether I could speak to SNMP to anything at all. Stalking the Wily Hacker, excellent ancient book, is the story of how Cliff Stoll set out to figure out why there was a quarter missing out of his accounting system and ended up tracking an international hacking ring. So this loose end following is worth doing. Once you have your pile of data, do some sanity checking. That's another reason you might be asking, why does the data look like this? Sometimes the answer to why does the data look like this is because you ain't collecting the right data. And sometimes your data collection reveals that, oops, your machine room is on room air, and that's just bad. So you have a pile of data. You have figured out that your data is actually the data you think it is. And now you're trying to figure out what to do with it. Step 1 is to sit around with the data and let it lead you. Know what questions you want to ask, but don't start out with an idea of what the answer to them is, because you will fool yourself. Humans are good at very specific sorts of pattern recognition. You often hear this as humans, excellent pattern recognizers. Ooh, they are. They are really very good at recognizing patterns. That's not always a win. It's a win when you have this. Is this machine broken? Yes, this machine is broken. It broke at now -3. How is it broken? I don't know. I know nothing about this. But there's no case of it working where it bounces around at about 82, kind of, varying on every measurement, and then it returns 20 solidly without ever varying again. That's broken. Humans are pretty good at that. They get that pattern. You can get strangers who walk into the room, look at that graph, and go, something is bad. That's excellent. It's surprising how hard a time the computer has at recognizing that this is bad. Humans are good at noticing abrupt change. They're good at finding correlation, finding things that are related to each other, and they're really good at seeing faces. You are evolutionary programmed for that. They are bad at evaluating probability. If it's happened to you, you think it's really likely. If it's bad, you think it's really likely. If it's not in your control, you think it's really likely. That is your reptile brain. It's very useful. It does you nothing of use. It keeps you from being eaten by giant lizards. Plus, it does not keep you from dying of modern hazards. Humans are also really bad at these two things are not related. You want things to be related. You desperately want them to be related. They're not very good at perceiving things changing slowly. If your power goes out, you will suddenly notice, hey, wait a minute. The machine room used to be very loud, and now it isn't. You didn't notice it getting that way, right? You just noticed that it changed. You're also bad at perceiving correlation with time delay. If A causes B, you're good at that. If A waits a while and causes B, you are going to blame B on C, which happened in between. And you can moderate that some, but it takes a lot of learning. I had a guy once who had a theory for how to make the CEO's computer work again. It involved installing the operating system every morning. One day I said to him, just for a lark, how about this morning you turn the computer off and go away for about as long as it takes you to install an operating system, and then come back. And hey, what do you know? Machine worked fine. The magic was in the delay. I mean, I've done that myself. I once developed a long way of making a makefile work that turned out to entirely have to do with a 5-minute clock slip between an NFS server and the mount point, and a version of make that behaved very oddly with negative timestamps. Human pattern recognition. Does anybody recognize that? Kermit. It's not a very good picture of Kermit, but it is undeniably Kermit the Frog. The difficulty with this is that it is also undeniably a crater on Mars. That's why it's a really bad picture. We don't take really good pictures of Mars. We're pretty certain that there isn't actually intentionally a picture of Kermit on Mars. That's just humans being really, really, really good at pattern recognition, even when there's nothing to recognize. That's one reason that you need to do actual close looking at your data, because the first thing that leaps out at you might not actually be there. Oops, wrong direction. All right. Let us suppose you have found your data, you have tracked it down, you have decided what it says, and now you want to show it to somebody else. This is the opposite of analyzing the data. You don't want, the data will not speak for itself. You have to decide what you want it to say, and you need to display that with only minimal other facts. Here's a brief course on not laying with graphs. Up is good, down is bad. Humans think that way. So this is bad, because that top line there says 76.13% bounce rate. Bounce rates are bad, yet this is charted with, this is 3 variables being charted. 2 of them are better the higher they are. 1 of them is better the lower it is. They're all charted exactly the same way, one on top of each other. It will lead you to be falsely happy about bad results. How not to draw graphs. Humans perceive area. So here we have little seals scaled to the bars. The data is completely, totally meaningless. It's the test data that comes with Keynote. But the fact is that the final piece of data is about 4 times the initial piece of data, except the final seal is more like 16 times the initial seal. And you don't know that consciously, but the back of your brain knows that. And it's going to overestimate those numbers. So what you can do about that is make the seals ugly instead. That doesn't really help that much. Sorry about that. Oh. Sorry, we have to do the seals again. Yeah. Now they're all proportional. They're just ugly. So just give up on the whole pictures. So that's humans perceive areas. What do I mean by not well? That's a pie chart. Pie charts are bad. Pie charts are bad because humans don't perceive area well. This one happens to only have 4 data points, so you can actually make out some data on it, but you're not really good at telling relative size of pies. So that is a gratuitously horrible pie chart. There is really no reason to do this unless you actually want to obscure the numbers. All right, one more piece of almost complete gratuitousness. This is how to display data in fascinating ways. This is an artist called Chris Jordan. You may be sitting here thinking it's a Syrah because it's, Saturday on the Grand Shot. There's a zoom in. At this point, we can tell the pixels are kind of rectangular. And if you zoom the rest of the way in, you can tell that the pixels are, in fact, soft drink cans. Why do I have this thrown in under analyzing data? That's about 1 day's worth of soft drink consumption in the United States. And it's fairly gratuitous, but it is an interesting way of displaying the data. He has a website, which I will mention later, and it's just the coolest data display ever. Okay, more not lying with graphs. Always put a 0 line in. This is a graph of people who are for and against President Obama winning the Nobel Peace Prize. All the numbers on this graph say 50%. It has a blue bar for no, which says 50%, and a red bar for yes, which says 50%, and they are very much not the same size. There's a big red yes bar that says 50%, and there's a legend across the bottom in case you're confused, which says that it goes from 50% at the low end to 50% in the middle to 50% at the high end. So it is not at all clear why the bars are different sizes. Well, the answer is the bars are different sizes because, in fact, there are 8,154 votes. And yes is ahead of no by like 3 votes out of 8,154. And it's being displayed, instead of off a baseline of 0, off a baseline where they differ to maximize the difference. It's just that the difference is then too small, so small that the software rounds it off in display, leading you to this extremely, and nobody can read this, but my favorite part, it's a Facebook poll, so what it says underneath it is, this is a non-scientific user poll. Could hardly be more true. That's why 0 is useful. Here's why 0 is not useful. I told you we'd get back to human subjects. If you have a help desk and you want to measure its performance and turn it into numbers, because you like numbers, you could measure time to resolve, but everybody will hate that because people will tell you your problem is resolved when it isn't, or they will shove it off to somebody else just to get it off their hair. So you could measure customer satisfaction. That's the problem with that. It's a self-selected sample. Why do I care? Well, number one, because most of the people who answer are the people who either hate you or love you. People who had a kind of customer service experience don't bother to fill out the form. They just move on. Who else fills out the form? People who follow instructions. Okay, why do you care? Well, you could be working at a company full of engineers. Engineers, do they follow instructions for the hell of it? No. Admins, do they usually follow the instructions? Yes. So you have just divided the company into the technical people who don't answer your survey and the non-technical people who do answer your survey. Why do you care, part 2? Well, number one, you have a lot more technical users than non-technical users, so you actually care what they think. And number 2, the same people who answer the survey are people who give out 5s if the rating is 1 to 5. Engineers do not give out 5s. If you tell an engineer that the possible rating scale is 1 to 5, and they like you, they give you a 4. Because tomorrow, they might love you, and then they would give you a 5. They probably won't, but they might. So they give you a 4 so that they have headroom. We all are totally okay with this. But the world is also full of this other class of people who, if they like you, give you a 5. They're quite consistent about it. I liked you. I see nothing wrong with that. I'm giving you a 5. So what happens here? Well, we get help desk operators who say the users are miserable. We get help desk management who's nothing wrong with the numbers. These are the numbers. These are properly charted from 0. There's nothing wrong with these numbers, right? They're floating up there, right? This kind of bumpy line might go down a little bit. Pretty much it goes in a straight line across the top of the screen close to 5. All right, let's chart it badly instead. Oh, well, if we only chart the space from 4.75 to 5, the difference got much bigger. Last time we did that, it was pointless and made everything look wrong. This time, yeah, that looks like a downward trend. Looks bad. Doesn't help. Management doesn't care. So let's chart something else. There's customer satisfaction. There's the percent of people who gave you a 1, which means I hate you, because they're not allowed to give you 0s. They can only give you 1s through 5s. That line kind of trends upwards, but again, it's not going much anywhere. That's the number of surveys returned by people in engineering. That line is going somewhere, and it's going straight down. And what that tells you is, what's going on here is you're pissing off the engineers. First, they tell you they hate you, and then they go away. Once they've gone away, they don't tell you they hate you anymore, so your numbers go back up. I would like to say that I presented the actual version of this graph to management, and they said, oh, how persuasive, and did something about it. Actually, they said, oh, how persuasive, why don't you go do something other than customer service? So I did. All right. I'm almost out of time. So, well, I am morally out of time. Some relevant books, they are fun. Some classics about how to lie and not lie with statistics. So this is a pair, How to Lie with Statistics by Darrell Huff, How to Not Lie with Statistics by Tofty. Blogs about data, junk chart, Chris Jordan, who is the guy with the amazing pictures. He has dozens more. They are all amazing. I want to see them full size, because full size, they would take up that whole wall. Chart porn, it's not that interesting. Sorry, but Chris Jordan is as close to chart porn as it actually gets. And these are blogs about data that are not actually about computer science. In the interest of full disclosure, Language Log does pay my father just as much as you pay them, which is to say nothing, but he posts there. And I lied about the transitions. One last would be transition. And are there any questions, understanding that you will be cutting into your ability to get whatever marvelous comestibles are outside?
I'm very aware of that last bit, having been told that I needed to work on getting my last performance review up above 4.7, because the average in my department was 4.9 out of 1 to 5. So what would you say about a cultural issue that I've seen in an awful lot of companies, where management really, really strongly believes that a bad metric, even one that has been shown to be, perverse in the policies that it promotes, is better than no metric at all? Is there anything that it begin on, or do you just go say, well, this is a broken company and you have to go somewhere else?
What you can do about bad metrics, in some cases, is, if it works, sometimes it's worked for me and sometimes it hasn't, is to replace them with better metrics. People who believe that a bad metric is fun are not willing to replace it with no metric at all, but they may be willing to replace it with a better metric if you can produce it for them. If you can make the charting swishier. For instance, if their old metric is a number and your metric comes color-coded red, yellow, and green, don't knock it, it works. I have done that before. I have taken numbers where people said, this is a number, well, perhaps you think it's a meaningless number, but look, it's a number, and said, look, here are numbers that are even cuter. You know, just because they wear suits doesn't mean they don't think cuteness is important. And produced other numbers that I thought actually had some relationship, if not to truth, at least to getting people to do what I wanted them to.
And in the case where it's a qualitative or a subjective thing, and so somebody stuck a totally artificial number on it, and so the real solution is to get rid of the metric?
There's just no getting rid of numbers for people who think they mean something. Occasionally in this situation, it is useful to think less like an engineer. In that if other people stick their random numbers in, overcome your moral imperative and stick your random numbers in.
That's all the time we have.
Thank you.